Well, hello there. I want to show you a little demonstration that I think illustrates the long chain nature of polymer molecules. I'm going to work with a six-pack ring, and my wife always gets mad at me because I collect them for this demonstration. I'm just going to tear a little piece of this plastic off. This is polyethylene, and the repeat unit of the polyethylene molecule is just CH2, 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 maybe 100,000 times or a few 100,000 times. And when that polymer is extruded or molded, the chains generally end up all every which way like spaghetti. Now, if a polymer chain were the thickness of a cooked spaghetti noodle, it would be about as long as a football field. So you can imagine how tangled those chains must be with one another. And that's what gives polyethylene its strength. It's really chemically very similar to wax or to gasoline, but because the molecules are so long, they get all tangled up with each other. Now, if I take this sample and I stretch it a little bit, well, that's not a good one. Let's try stretching this here. I want to form a little neck where it narrows down a little bit. And as I stretch it, the polymer chains are moving past each other and they're becoming aligned with one another. So pull it a little bit further here. So it's getting thinner, it's getting a little bit narrower. The chains are getting aligned with one another more or less. And so if I get this enough, try to do it without breaking. Let's see if that's far enough. Then I should be able to separate this into, okay, we got to stretch it a little bit more. Just don't have a good grip on it. Get a grip, man. Get a grip. Okay, so I've stretched it, and now I can, believe it or not, separate this into little fibrils. Parallel to the stretch direction. And you can't do that down here. You can't separate it because the chains, the polymer chains, are going every which way. But up here, where I've stretched it, I've aligned those chains. And this is actually now stronger in the stretching direction because the polymer chains are lined up. And it's weaker in the transverse or across direction. And that's how come I can separate this into little strands. So I think that's kind of cool. And this also happens when pop bottles or water bottles are made. That's made by a process called blow molding. And they start with a little preform, put it inside a mold and heat it up, and they blow air inside and it puffs up. And in that stretching process, the bottle gets stretched both along, parallel to the axis of the bottle, and around the edge. So it's called biaxial orientation. And that makes the bottle much stronger and capable of holding the high pressures that soda pop requires. Well, I hope you found this interesting. Bye-bye.